Hello and welcome to the second part of the advanced deep dive looking at procedural generation. So where we got to last time, we had been generating our biome map and we'd been experimenting with generating this at different resolutions, and we tied that to the height map resolution of the terrain, which what we were finding there was if it was a really high resolution, it was something where it was taking a very long time to generate. So what we want to do in this video is, first up, we want to be able to return back to having a high height map resolution, so we get really fine-grained terrain, and we want to unlink that essentially from the resolution of the biome map. So we want to be generating our biome map at a low resolution and then scaling that up. So that's what we're going to take a look at to begin with. So we already have our configuration objects for the generation, and we previously just had stuff in it for the number of biomes and the density. So what we are now going to do is we are also going to set up a option to configure the resolution of that initial biome map, so the low resolution one. So this is something where what I would do for this is I'd actually probably set up an enum. So biome map resolution, and maybe I might call it base resolution. And I'm going to set up a couple of predefined entries in here that we can be referring to. So size 64 by 64 is equal to 64. So I'm going to make it that the values equal the particular size, just to make it really easy for being able to extract the values then, because I can just directly cast the enum to an integer. And let's chuck in just one final size. I'm really only going to be using the 64 by 64 one, but conceivably you might want to go for higher resolutions, and it just means that this way we've got a bit more control over it. So that works. Then we can have biome map resolution, and I'm going to default that to 64 by 64. Excellent. So the next step then is in my procedural generation. Well, conveniently, I was already using a number that I was passing in. So I don't actually need to change most of the rest of this code because it's all tied to that resolution that I was passing in. So what I can do is here at this point, I can access my config, biome map resolution, and cast that to an integer. So this is going to generate the low resolution biome map. Actually, generate the biome map. I'm going to keep it with it being separate functions. So I'm going to have this generate the low resolution one so that I can have the high resolution generation in a separate function, just to split things out a little bit neatly. So in this case, save out the biome map, and the biome map low resolution. So I won't need to change anything else. That will give me that data as a low resolution one, which is great. Now I am going to rename these. So this is where the rename symbol function comes in handy. So I can rename all of these. low resolution. Because what we'll do is once we've generated it at that low resolution, which let's test and make sure that still behaves the way we want, what we'll then be able to do is we will be able to upscale that. So I can see now I can get rid of that old one, but my low resolution one, so that's worked. So cool. So what I need to now be able to do is, because I still actually want my high resolution ones, I need to be able to upscale. So biome map, and I just have it like that. I'm going to say that that is the high resolution one. And this is something where if I started to get into a lot of extra things here, I would be considering setting up like a biomap class that holds this data. It's already getting close to that point where I would be doing that. It is borderline. I think if I had one more variable that I was tracking for the biomes, I would absolutely be setting up another class there that holds the biome map. That's usually my threshold when I hit sort of 2-3 variables. That I start looking at doing that. So I've got the low resolution one. So now I want to generate the high resolution biome map. So form biome generation, high resolution. So just to make things a little bit easier, I want to give it the resolution for the low res map. And then for the target resolution, because what that will allow me to do is, so I've already got my spawn individual biome. I'm going to put this function here. I'm also going to just go and collapse these functions to make, and variables, just to make it a little bit easier to see everything. Cool. So low res map size, high res map size. So okay, I'll know the different resolutions there. I can also grab the initial setup here, just for honestly, because I just want to have to type less. So this is biome map. Actually, this one's just biome map. So these are biome strengths. And these are going to be the high res map size. So what I need to do is I need to scale up my low resolution map to the high resolution map. Now the low resolution map, I've already done things where I'm converting that to an image. I could absolutely use just the built-in image functions to take this image at this resolution and scale up. I would absolutely be able to do that, but that will encounter some problems because there's different aspects to that. So one of the key things there is the way a lot of the sort of upscaling of ones will happen is there is interpolation between the values. So those boundary points between biomes. So if we load up our biome map, we do have boundary points here. So those boundary points, what it would do is it would interpolate between those values typically. And it would interpolate using its own processes for that, which what that could mean is, because what we're writing out here is the indices for a biome. So a biome, and if we look at our configuration, we'll be able to see. So what it would be interpolating between is, okay, well, one pixel might be 0, another pixel next to it might be 4. So we've got bush next to swamp. And then when it scales that up, it could say at the midpoint, well, it's the midpoint between 0 and 4. So it's going to be 2, which means between bush and swamp, we'll put rainforest. So if we let it just freely do its default ways of doing interpolation, then it's going to generate additional biomes in areas where we hadn't planned them, and ones that would not necessarily make sense. And what we would get is on the boundaries of different biomes, we'd always get extra layers of ones, which is not really going to give us the visual we're after. Now, there might be cases where we might intentionally do that, where we might spawn biomes that, we might spawn only biome 0, 2, and 4, and we use 1 and 3 actually as buffer or boundary ones. That might be a deliberate thing. But for the setup we've got, it's not what we're after. So we need to be doing this upscaling, but we need to do the upscaling where we're controlling how that blending is happening. So let's have a think about this. So what I need to be able to do is I need to populate every pixel of my high resolution map. So let's start with that. So the starting point, I'm going to need to be looping over every single pixel in my high resolution map. So we can start just with that. So, okay, I've got looping over all of the particular ones. Oh, it's map size. Cool. Okay, so now I'm going to need to do this because I need to make sure every pixel is populated. Now, for every pixel in the high resolution map, I could work out the equivalent pixel in the low resolution map. So that would be something I would be able to work out because there is a scale between the two maps. So how I could work out that scale is map scale. So depending upon how we want to work with this is going to determine how we calculate it. So it's either going to be high-res map size divided by low-res map size, or low-res map size divided by high-res map size. Depends on how we're wanting to use it. So I know that what I'm going to want to be getting out down here is low-res Y is going to be Y multiplied by, I ideally want it to be able to be Y multiplied by my map scale. So if I'm multiplying by my map scale, so multiplying my high-res coordinate by the map scale, I know that what should happen is large values should become smaller. So if a large value should become smaller, then that means my map scale should be less than 1, sorry. So I'm going to have low-res map size divided by high-res map size. Now, if I just did this, my map scale would be 0. I need to remember and cast one of these. I don't need to cast both. I often do, just for the sake of I find aesthetically I'll prefer the look of that. But this is my normal preferred approach. I'll use float for both. It's not necessary, we only need it for one. So now I've got my map scale. So that if I multiply this map scale by a high-res value, I'll get the low-res. So that's pretty good. But I'm doing an integer multiplied by a float, which gives me a float, which means I need to, what I would normally do here is, usually I would do a floor to int. So you could do a round. The reason I usually do a floor is because that way then I know in every case that this is always going to be the lower of the values it could be. So it gives consistency to it, because as that y value goes up, there will actually be a midpoint where it then switches over. So in this case, I prefer to use floor to int for this. So what I'm doing is calculate the high-res map, calculating our map scale. So I've got my low-res Y, and I could also get my low-res X is going to be similar, floor to int, X times map scale. So straight away with that, what I could actually do is I could say, well, okay, well, my biome map at XY is equal to my low-res one at X comma Y. So I could just do that, and I'm going to grab the code for outputting it so that we can see what that high-res one then looks like. So this, we are using our high-res map size, and we're just grabbing it direct from Biome map, and this is our high resolution. So let's just take a look at what that appears to look like. Just give us a good initial sense of, okay, is it looking a way that we're happy with? Is it not? So we are getting an out of range. So this is something where we want to low res X. I clearly needed to have another coffee. Let's try it now with the correct lookup values there. So we'll get this up and running. Regenerate the world. So, okay, this is our low res one. Let's take a look at what our high res one looks like. So high res one looks all right. It is very sort of blocky, but that's exactly what we would expect. Now, okay, so I'm going to actually save this of no filtering. That's what I'm going to call that one. So that's the no filtering one. Because just like how with images, there's different algorithms for when we're doing upscaling. So this, I'm doing more a point-based, it was a point-based algorithm. It just expands it directly up. I can actually do a better approach. So I can actually do an interpolation, but I can do an interpolation where we are still constraining it to be particular values. So what I would be using for this is a common upscaling algorithm for images called Bilinear Interpolation. So let's take a look at how we set this up. So this, I'm going to turn off. And this will do no interpolation, point-based. So what I want to be able to do is I want to have, okay, a upscale P. No, I'm going to have interpolate, calculate, I think is a better term for it. So calculate high-res biome index. So I know I'm going to need to give it my low-res X, my low-res Y, high-res X, high-res Y. So now I'm going to need to do that. And what it's going to do is, so if I wanted to just have it do the previous approach, I would just do low-res X, low-res Y. So that's going to do no filtering. So I'm going to change this to biomap XY, low-res X, low-res Y, and then X and Y. Just so I'm feeding through those particular ones. So that gives me, why are you grumpy at me? Oh, because it's a byte. Of course it is. So that'll give me it routing through that function, which means I can now start to do the actual bilinear interpolation part for it. So the way bilinear interpolation works is it needs to work out essentially the 4 points surrounding a location. And it needs to know how far we are between those points. So this, where I'm rounding down, there's going to be cases where, so for example, this might have given me back a value if I didn't round, and I had it in a floating point number, I might get a value of 1.1. That fractional part, that 0.1, is what we're actually after. So what I need here is my, let's call it, y fraction. Okay, so to get the y fraction, what I would do is I would do my original calculation, y times map scale, and I just need to subtract the low resolution value. That'll give me the fraction. Now, there are definitely other ways that I could be calculating this. There are absolutely other ways I could be calculating this, but I'm just going for the simplest sort of setup at the moment. And this is stuff that, although it's running a lot, it's running in editor side, it's not super performance critical, it's going to be, give me an effective result. So, okay, I've got my y and x fractions. So my high-res biome index, I do need the low resolution values, but actually I don't need to give in the high resolution values, but I do need these fraction components because those fractions are what I use for doing that interpolation. So these are going to be fraction x and fraction y, because those I can then grab my points at the different corners. So that's the next step of what I do with this, is I actually go and I grab my components. So I have my, and this will be, and actually we normally will convert these over to floats. So A is going to be biome map low resolution, low res x, low res y. Then, unsurprisingly, I also have B, C, and D. So these are at the corners because it's bilinear, so it's across two axes, and I am getting the points at all of the corners. So we have x plus 1, y plus 1 for D. So these, we want to, which ones, the order that I'm retrieving these in does actually matter, because it determines which ones we're using the fractions between. So with this, I'm going to be going for this setup, and then plus 1. Excellent. So this gives us, and I'm going to line these up just for neatness. So we've got our 4 components. So our A, B, C, and D. And then our fraction actually indicates how far we are between these. So if you think of it like a square, what we are doing is those fraction components say how far along, what percentage between A and B, and between each of the ones we are, to give us a location within that square. So that's what we're working out. So our filtered value, so perform bilinear filtering. So our filtered index, I'm just going to call this index. Yeah, index. So I do not remember this off the top of my head, and so in the interests of making sure I don't actually mess this up, I am going to be going from the version I wrote down in my notes earlier. So this is where we are using the different components. Now, you might recognize this as what it is effectively doing is there is a linear interpolation happening, but it is a linear interpolation in 2 dimensions. That is actually what is happening here. So C times y, so fraction y, times by 1 minus fraction x. Fixing that up. So yes, it is a linear interpolation in 2 dimensions that is happening. Plus the final component, fraction x, times by fraction y. So this is just doing direct bilinear filtering. Now that I could just do a round to int. Round to int should be safe with that, of index. And let's see what that looks like. We need to cast that to a byte. So let's take a look and see what that looks like. We're running through and it's doing the filtering, but we're not doing anything extra to ensure those values sit within suitable ranges. So we did manage to get a value outside of the array. Let's just run this again to double check. So this is managing to just go out of range. And what this will be is when we get to the very edge of the map. So if we're at the very, very edge of the map, it's going to be able to be going slightly off the bounds there with that. So that's something where there's a few different things of what we could be doing there. So we could be checking if those x values are valid. If they are valid, then you're allowed to go through. Otherwise, what we could do is we could be reducing those particular ones, so we could actually be clamping low resolution values there so that they can't go beyond the bounds of the array. Or at those points where, because that will happen, because we're flooring, that will really only happen if we're at the very, very, very edge pixel. So what we could do in a case like of that is for those ones at the very edge, we just don't do any filtering. So what I could be doing here is something like of this, where f low res x, actually what I could do is do this logic here of checking. So okay, well, if low res x is equal low res x plus 1, check that against the resolution. So in this case, I would make it that we are passing in the low res map, low res map size. So I'm going to change this to also be feeding that in, because what we can do is, well, if low res x plus 1 is greater than or equal to the low res map size, which I'll do is less than res map size, then we use the normal logic. Otherwise, we just use A. And then I can do this same check here, but I'm checking with Y. And in that case, if it has been the same, then again, it would be A, because we know that we can't go to the next value. And so then this one, if either of those are the case, then this needs to be a different value. So we could do a similar thing here, where what we are doing is, and this one it might need to be a bit more of a complicated one. So this one, what I might end up doing is, okay, well, if the low res x plus 1 is greater than or equal to low res map size, then actually no, what I will do, yeah, no, that's fine. So if the low res, I'm going to start that at 0. If the low res x plus 1 is greater than the map size, or in that case, we would use so we know the x is invalid, so we would use our value for C. Otherwise, if low res y plus 1 is greater than the low-res map size, then we would say D is equal to A or B. I think we'd go B in that case. So if Y is invalid, then we can only go to low-res export. Yep, so that would work. Otherwise, we do that. Otherwise, D is equal to that. That will do the trick. So we're just falling back to particular values. So what it'll mean is that if we were on the edge of the map, that it's not going to be trying to interpolate those ones. And I believe that was all good. So let's take a look and see what this looks like now with the bilinear filtering. So we end up with it looking like that, which is not really what we're after. You know, this was the unfiltered one. So the filtering, it's because it's interpolating between values. That means it's able to change, and that's less than ideal. We don't want it to be able to be doing that. So we need to have this actually picking from a specific value. We need it to be selecting particular ones. So what I would often do for this is, so that's the filtered index. So we've got our filtered index. So what I would do is I would extract out what the candidate values are. So candidate biomes. And so the candidate biomes is going to be A, B, C, and D. So I want to pick the best value. So I want to pick the one of these biomes that is the closest to the filtered one. So what I'm saying is that this will only return one of our valid biomes, but it picks the one closest to the filtered value. So what that means is I'm going to need a best. So I'm going to have here the best biome, and I'm going to default that to the first one. So it gets defaulted to candidate biome 0. And then I'm going to have biome delta, so the difference between the biome. And so that's going to be my max value. So then what I want to do is loop through each of these biomes. So biome index 0, biome index is less than candidate biomes length. And actually, I don't need to start at 0. I would start at 1. So we've already chosen the first biome there. No, actually. Yeah, actually, I'm going to set best biome to be -1. I want it to be an invalid value because I can always pick, this should always generate a particular one. So what I can do is work out the delta. So this is going to be the difference between the filtered index and this particular biome's index. Biome index. So that's going to be the difference. So that works. That gives me the delta. So then what I can say is if delta is less than, actually that should be best delta, is less than best delta, then I update best delta to this. I update best biome to the candidate biomes biome index. And then what I return here is I use that. So I use the biome, best biome there. So what I'm doing is, this is build an array of the possible biomes based on the values used to interpolate. Then what I'm doing here is find the neighboring biome closest to the interpolated biome. So it's meaning that I won't get fractional values. I will only get fixed values there that tie to the particular biomes we've already got. So let's see how that looks. Regenerate that, and let's take a look at our high-res map. So that is looking a bit better. We've got, it is upscaling a lot, but we've got patchy bits, which is fine. But those patchy bits are looking a little bit better if we compare it to the high-res with no filtering. So we've got high-res with no filtering and the high-res with the filtering. So on the left is with filtering, on the right is without. So we can see we get sort of softer edges when we've done the filtering-based approach. Now, what we could do, we're not going to do in this particular one, but what we could be doing is we could be saying, okay, that fractional amount, we could use that to lower the intensity of the biome. So we could use that to actually allow multiple biomes to be in the same location, but we filter out, we fade out the intensity of the biomes there. So that would actually be a fairly effective approach if we wanted to do that. We're not going to do that at this stage, but if you're looking for ways to extend it, that would be absolutely a thing that could be done. If I zoom in this, which I wish this program allowed for more zooming in, because this is a really, really weirdly small amount of zoom that it lets you do. But we can see how these structures have scaled up fairly nicely. There is definitely further bits and pieces we could do on this, but this gives us our initial point where we've now got a high resolution map. Okay, so we've got our high resolution version of the map. Now we actually want to start messing with the terrain, because we've done a whole bunch of stuff for generating this, but we want to actually be changing the terrain now. So that's going to be the next step. Perform, not biome generation. So perform the, and I'm going to call this height map modification. Again, I'm going to feed in the map resolution. So this is going to update the terrain heights. So this is where we're going to need to set up again a bit more infrastructure for this. And the process here, we're just working with the heights. So we've worked with the biomes to work out the general structure of the environment. We're going to then modify the height map to change the elevation of the terrain. Then we do texturing, then we do placement of objects. So the height map generation, what we want to be able to do with that is, again, passing my map resolution. So with this, there's a couple of different stages if we think about this, of how we can approach this. Because each biome, we probably want it to be able to customize how it generates the heights there. And often with the height modification stuff, there's different things that we want to be able to stack together. And we probably also want some post-processing that we can do. So this is where we do need a whole bunch of infrastructure. And what I really recommend setting up for this is, and this is an approach I've used that I find really works quite nicely, is I'm going to set up height map modifiers, we're going to call these. So the idea is going to be that we have a whole bunch of modifiers, and these are going to be like colors in our palette. And we can pick from different ones of these and apply them. We can change the order that they can be applied in. So a bunch of different things like of that. So I'm going to set up a couple of ones. So I'm going to have my base height map modifier. This is going to be the base class for all of them. I'm going to have another one that what it is going to do is it's going to be a height map modifier. So I'm going to have this be a noise-based one. So I'm just going to set up a couple of different ones. I'm going to have a noise-based one. I'm going to have one that is going to be applying an offset, so it can just shift things up and down. Let's also chuck in one for a pure random. And random. So 3 different ones, that's a good sort of starting set of things. And then what I'm going to do is make sure, so none of these are going to need a starter and update. So I've got my base one. These will all inherit from this. And this will be again a case where I want to think about, okay, well, how do I want to use these? What do I want the behaviors to be there for this? So I am going to want to have some modifiers that are tied to each biome. So each biome is going to need to be able to have a set of modifiers. Now, this is where I'm going to do something that's a little bit weird. Because the easiest way for me to actually do this is if I have a game object, height modifiers. So this is going to seem really strange, but what this is going to be is this is going to link to a prefab. So I could have an array here of my base height map modifier, but then I would need to do a lot of custom inspector work for that. This is something where what I find is a more effective method is I actually set up a prefab and put these scripts on the prefab. It sounds like a weird setup, but it does actually work really well. What I would then do is similar for the overall procgen config is I would have my initial pass ones, so height, so initial height modifiers, and then height post-processing modifier, initial height modifier. There we go. So I do something like of that. So what I can have is the overall procgen can run some modifiers, then the individual biomes can run, then I can run some post-processing there. So just as an effective way of being able to work with these. So I'm going to have those. I'm also going to set up another height modifier that what it's going to do is it is going to be a height map modifier set value. So it's going to set the height to a particular value. So okay, let's start to think about what bits I need in here. So, okay, I'm going to need to run the modifiers on the base object. So I'm going to need stuff because these are going to be different components because this will allow me to attach the same component multiple times as well. So I know one of the common things I'm going to need is these modifiers are going to need a strength. So I'm going to have a serialized field that is also a range from 0 to 1 that is protected, so the child classes can access it. That is going to be the strength. So I'm going to default that to 1. So this is going to be how strongly the modifier is trying to be applied. Let's get our set value 1 to be inheriting from base 1 as well. So strength is going to be a common thing that all of them are going to need. Let's look at our set value. Well, set value is going to need a float for a target height. That'll do. I'm just going to leave it as 0. So, okay, set value will have a target height. My offset 1 is going to have a offset amount, because that could be positive or negative to raise or lower things. So that will work. Random, that is going to also have a range in terms of the height offset that it can apply. So height delta. You'll notice I'm defaulting all of these to 0 so that they'll have no effect. So I'll have that. So that works. So what I want to be able to do is, I know my config has the height processing, sorry, the initial height modifier. So if I've got that, so if have that, then what I want to be able to do is get components, and if I do get base height map modifier, so I do that on config initial height modifier, get components, that'll give me back all of these height modifiers to apply. So okay, that works, because what I will get back is modifiers, and then I can execute those. So this would execute any initial height modifiers. And then I'll have a similar thing down here at the end for the post processing. Post processing. So I don't need to actually run these. So for each modifier in modifiers, then I need to actually execute it somehow. So if we think of the things it's going to need, so I'd have modifier execute. Well, I know it's going to need the biome map. That's a given. It has to have that biome map. I know it's, I don't need to give it the map resolution, but it saves me doing a function call to retrieve the resolution. So I'm going to need the map, I'm going to need the resolution. I'm going to need the terrain to actually be working with. So I've got my target terrain, but I need to actually give it the terrain to be working with. So I can give it the direct terrain, but the way we actually work with the terrain for changing the heights is if we take a look at our terrain, and it's target terrain dot terrain data, and then the heights. So I could be directly working with it, and I could in each one, do this get heights or set heights, things like that. That ends up being a lot of extra calls to that I don't need to. So what I would normally do is do get heights, and I need to give it the range of values, which I just give it the entire map. And that gives me back my height map. So rather than passing in the terrain and then using get heights in every single modifier, what I would actually do is just have my height map and pass that through. So I've got the biome map, I've got the map resolution, I've got the height map. Now, an important thing with the height map is it is a grayscale image. It's values from 0 to 1, which I need to then, my modifiers, I don't want my modifiers to have to work in that range. I want to be able to use meters. So that means I actually need my scale. So I can pass in the target terrain terrain data, height map scale. And this gives me the scale in all dimensions. So width, length, and height. So any possible conversions I might need to do, I can actually be doing there. So that's cool. I've got my biome map, I've got the map resolution. So that seems fairly reasonable for the initial height stuff, for the post-processing as well. That looks pretty solid. What about for executing the individual biomes? So I need to loop through each biome. So biome in config biomes. So that gets me the biome config for each one. So biome, well, I know it has the weighting, and I have the actual biome object there. So this is where I can access the height modifier. So I'd be able to do a similar bit of logic here, where I have modifiers and I retrieve the components. And then, so okay, I run height map generation for each biome. And I know I need to execute those modifiers. So all of that looks pretty straightforward, but I don't want a biome modifying things that it doesn't own. So that means I need to make sure I pass in the particular biome. So that's going to be additional info that I need. So, okay, let's pass that in. So I need to be passing in biome, the actual raw data object for it. So that's okay. But my biome map has indices in it. And I need to know what index I currently am so that I can make, because this object doesn't know what index it is. So I need to pass through extra information so that the modifier only touches its own actual data. So what I would need to do then is this, rather than it being a for each, I would do for int biome index is 0, biome index is less than config num biomes plus biome index, so that then what I can be doing here is config biomes biome index. I'm just going to actually store the biome here because I'm accessing it in multiple places. So just to make this easier, I would do that, and then that, and I would give it biome index. So, okay, let's take a look then to sanity check that we're providing all the info we need. So for our general broad scale modifiers, we're providing resolution. Now we probably don't actually need to provide the biome map for those. So that's something where I'm going to actually move the biome map to at the end here for the biome specific stuff. So our initial and post-processing ones, they have the resolution, they have the height map, and they have the scale data. That looks solid. And our biome specific one has that information, but it also has the map of all the biomes. It also has the data for its current biome and the biome index. I'm going to swap the order of those because that feels like it's more logical if it's that way. So, okay, that looks pretty solid. So we can set up our function then, and what I would normally do is something like of this. So public virtual void execute. So map resolution is an integer. Our height map we know is this. We know our height map scale is a vector 3. And we can remove all of that. So okay, that looks pretty good. I'm going to put in a debug log error here. No height map generation no implementation of execute function for game object name, just so we know that something's gone wrong. Could also throw an exception there as well. So we also then now need these ones that can take in our biome map, our biome index, and our biome. But these are things that will not normally be there. So these are going to end up being default parameters. So our biome map is a byte like that. Biome map, but we're going to default that to null. Our biome index, we're going to default to -1. And our biome config, we're also going to default to null. So now we're passing through the information, so we've got set up so we can actually start modifying these particular entries. Okay, so we've got our infrastructure for this. Now let's set up some of our prefabs that we'll be using as data for this. So the way this ends up looking is we would set up a prefab. So this is going to be height modifier initial, and under the procgen config, that's where we would link this. And so what this would do, this would be the first one that runs. We'd have our height modifier and set value. So I'm going to say that I just want the target height to be set to 20 meters. At the moment it's 0, I want to be setting it to 20. And we haven't configured height modifiers for any of the other things, we've just got our initial one there. So we'll get these each working in turn. So set value 1, we need to implement our execute method, because this will give us a sense of, okay, what does our structure for these look like for each of the particular ones. So set value is going to give us a good sense of that. So we've got our execute one. So we know a general given, we are going to be looping over all of the values. It's one of the things that we can guarantee every single one of the ones is going to be doing something like this. X is less than map resolution plus X. So then we need to work out what our new value is. And I'm going to fix up the naming of that because otherwise it's going to annoy me. So we know we are setting to the height map value here. So it's setting height map XY, and we know that we are setting that to a particular value, which we've got our target height here. So we know it's going to be target height. But then we need to use this height map scale, because remember, we need to have it be in our 0 to 1 range. So if I remember rightly, we just do height map scale dot y, I believe is what we would do. So this is going to be the super basic version of this. And then I will make it that we have target terrain, terrain data, set heights, and 0, 0, and height map. So what I would hope to have happen is when I hit generate, all of this terrain moves up. That's what I'm looking for behavior-wise with this. So we regenerate the world. Now we did get some errors. So height modifier, so this is where what I need to be doing is, because I was doing null checks here, but I did not do a null check here. So what I should have been doing here is if biome height modifier is null, continue, not that, continue. just so we're not trying to run the entries if there's actually nothing there. So let's try this again. And it is definitely moved. Something has definitely happened with our terrain. Now that's something where if we go, we can head all the way up here. Now that seems like it is probably been set to the wrong height. So what that may mean is that my height map scale is actually, I'm using it the wrong way. So I could debug it out, or let's just test. Because it's either going to be multiply or divide. I assumed it was multiply. I have a feeling it must be divide. We'll find out. There we go. And I can confirm that by, if I head down here, I can see that that does look like it's about 20 meters off the ground, which is good. So, okay, we can be applying it like that, but this isn't doing any biome filtering. So skip if we have a biome and this is not our biome. So if biome index is greater than or equal to 0 and biome map at xy is not equal to biome index, then continue. Actually, we could probably do this, because for biome, that works as a reasonable method. So, okay, that's cool. We're not using the weighting yet, so the strength should control how much it applies this. So what we could be doing is new height is equal to target height divided by height map scale .y. And then the actual one here is a lerp from the height map, its current value, new height by the strength. So calculate the new height. Blend based on strength. So okay, that's a fairly straightforward one. So that's our set value one done, and it handles different biomes. Let's go for our offset one, because that's another fairly straightforward one. Because in this case, our new height is going to be our current height. So this is going to be a little bit different. So we need to take our current height and we need to add our offset divided by height map scale .y. Just going to bracket that. So it's a slightly different calculation here in that we are reading from the existing value and then we can offset it. So that looks pretty good. So that will work for our offset modifier. Then we've got our random one. So random one, it's going to be fairly similar. Rather than having offset amount, we would have random range minus height delta to height delta. So we can see these modifiers are all pretty straightforward for a lot of them. That will work for random, and we will get to the noise one in just a moment, because what I want to now do is I want to set up a height modifier for post-processing. And this one, I'm going to remove the set value, and I'm going to add on the random and say that, let's initially say that the random height variations it can do is 5. So procgen config, chuck that in. Let's see what happens now. So, okay, 5 might be a little bit too strong for the random one. This is why you don't use pure random only for terrain generation. So, okay, let's drop the height delta to, maybe it's more like 0.25. So it can move at 25 centimeters up and down. Just to give a little bit of variation. And that looks better. That, if we are closer to that, that looks a much more reasonable amount. We can kind of see what the strength modifier will do as well, in that if I halve the strength and then regenerate, then it lessens those. So it damps it down even further. So I'm going to return that back to full strength. So, okay, that's pretty cool. Let's start to look at what we could do with actual noise side of things, though. So I'm going to, again, bring this over because it's a really solid template. So with noise, the main type of noise that we'll generally be using is one called Perlin noise. Perlin noise has really smooth changes between the values. It's also the way you get Perlin noise is you give it an X and a Y value. So it's 2D values to get the data, which works really nicely. So, okay, I know similar to the other ones, I'm going to have an amplitude or a height delta that it can apply. I'm going to default to 0. And we also have scale factors for the noise. So what I'm going to do is, okay, let's have our X scale. And I'm just going to default that to 1. Going to have our Y scale also default to 1. And then the way we use Perlin noise is we have mathf Perlin noise X times X scale, Y times Y scale, and that gives us back a 0 to 1 value. So we would then multiply that by our height delta, and we just swap that in where we had our previous height changes. So we're going to have it work as it's additive, and a lot of the mechanisms that we use at this point are additive, so we're adding them to the height map. Now this would only be able to move it up, and that's it. It could move it up. It wouldn't be able to make it move up or down. So what I would actually normally do is the noise value is I'll store the noise value separately. Noise value. Because the noise value is currently 0 to 1, but I want it to ideally be -1 to 1. So easiest way to do that is if I multiply this by 2, and then I subtract 1. That's going to give me something that, whereas before it would go from 0 to 1, after this it goes from 0 to 2. I just subtract 1, so I can move it up and down. So really straightforward setup. With this, I'm going to still do this on the initial one. So this is the benefit of having this sort of structure. We can easily just add things on top of the existing ones. So I'm going to say height delta wise, I want this to be really noticeable. So I'm going to start with 1. Let's just regenerate it. Okay, it doesn't look like it's done much. And it won't have, because these scale values, 1 or generally any integer value, so if I set that to 10 and then regenerated, we get the variation due to rand, but we don't get any other major changes. Your scale values typically here are going to be less than 1. So a good starting point is often going to be something like, in this case, let's go for 1 divided by 16 and test with that. So regenerate. Now we see terrain variations, and this is what Perlin noise will allow us to do. We get this big sort of up and down movement throughout it, and what our scales control. So that's with this x scale of that. And that was 1 divided by 16. Let's go to 1 divided by 32 for both. And we'll see how that changes. So they stretch out. So the smaller the value in the scale here, the larger the feature. So you'd use small values if you want to have sort of rolling hills, things like of that. Whereas if I used something like 1 divided by 4, then rather than getting really large features and a fairly sort of small number of them, what we'll find is we get lots of really small features. So the larger the scale value is here, the smaller the feature. The smaller the scale value, the larger the feature. And what we can actually do is we can have our Perlin noise run over multiple iterations. That's actually a common thing, where it have serialized field num passes equals 1. And then what we would do, we would have pass 0, pass is less than num passes. So we actually run the process multiple times, but we change our values each time. So rather than having our x scale, y scale, things like that, we have working x scale, which we started our initial value. We have working y scale, which again had our initial value, and we have working height delta. We started our initial one. So we replace all of our values in here, and then after each pass, we change them. So update parameters. So there's different ways that we could update this. So simplest version. So if we know that smaller scale values result in larger features, what we could do is, as we do each pass, we actually want to make progressively smaller features. So what we could do is working x scale times by, and this is where I could expose some options for this. So I could have x scale variation per pass, and maybe I'm going to make it that it doubles. I'm going to do similar for y, and then I'm going to have one for the height delta. Now with height, I want the values to decrease. So I'm going to say it's 0.5. So my x scale is going to change. Going to then do the same for y, and then also change the height delta. So what this will do is, as we have progressive passes, each pass, the features that it generates will become smaller, and will also, so smaller not just in the width and length, but also in their height. So I'm going to chuck the height delta here up to 20, so it can change a larger amount. Now it is just at 1 pass currently. So let's take a look and see. This is 1 pass. If we run it again, and now let's make it that we have 2 passes. So it's 2 passes that are running. Then we can see it starts to break it up. We can increase the number of passes even further there. So I could say, let's go for 5 passes, and let's see what we get. So it runs. Now 5 passes, it ends up being really, really busy and messy, but we can adjust our settings further. So, we could be changing here, and that we can see it's actually modified the height delta, not the working height delta, so let's fix that. That was a bit of a mix-up on my part, because remember, if I modify a prefab, it's in code there, it is going to actually change. So let's change the height delta back to 20 and rerun that. So this is what will happen as we have more passes. We can start to get things where this is looking a lot more like a mountainous terrain. But then if I changed my settings here, so let's make it that we're actually starting at 1/32. Let's start at 1/64. So we're starting at a much smaller value there and regenerate. So again, it's still rocky areas, but it's actually a lot less. And we could keep making adjustments here. We could make it that, well, rather than the scale, doubling, maybe it's only changing by 1.5. What does that look like? So that then is giving us sort of smoother, more rolling terrain. This is an initial height modifier, so probably don't want it actually modifying stuff too much. So that's where I could drop that strength right down, so that then it's not impacting the world quite as much. It is a bit, so it's still providing a bit of structure, but just a very broad stroke structure. And what this lets me do then is I can now turn most of the processing over to the individual biomes. So if I set up a prefab, and this is going to be height modifier bush. So for the bush one, I'm going to make it, let's take a look at my modifiers. I'm going to just have the bush one apply some noise, but I want it to be just one pass. Can modify it by sort of 5. I want to have a really large feature set. So I'm going to make it 1 divided by 128. But I'm going to keep it as a single, actually no, let's go for 3 passes. So it's going to be just for the bush. The bush is going to do that. So we can link that one up. Then for the grassy plains, I'm going to use the bush as a base one for it. But the difference there is grassy plains, I want it to have more height variation. I want it to be larger features, also smaller features for it. So again, I can link it up. I'm going to say that scrub is going to just be, for now, exact same as the bush one. Oops, I duplicated the biome rather than duplicating the modifier. So bush, that's going to be same as for scrub. So we link that up. So these will run. Then I've got rainforest. So rainforest, I'm going to take the one for bush, but I'm going to really ramp up the height delta. Still give it a large number of passes, but I'm also going to give it an initial height offset. So for rainforest, I'm going to initially bring that height up by 10. And the order matters here. So by putting offset first, it will run first. So it will move things up, then it will do height changes. So that's good for the rainforest. I'm going to bring that one in. And then swamp, I'm just going to use bush, but again, I'm going to have a offset that again I'm going to put first, and this is going to lower it. So just want to lower it, then let it modify the terrain. So what I've done is configured different sets of modifiers for each of these. They're there as prefabs, so it's easy for me to mix and match, test different ones. And now we can test what happens. And so we've got areas where it is lowering it, based upon it being a swampy area. And we'll get little pockets of things. That's something where we could also run a post process that filters out those little pockets. So just because we've generated the biome map doesn't mean we need to stick with that as, yep, this is what it's going to be. We do nothing further. So that looks pretty good. We probably want to have a bit more blending between these though. So what I often have is, as a final modifier, I would have a Height Map Modifier Smooth. So what this is going to do is, the idea behind this modifier is it smooths it over a range. So this is going to have base height map modifier, and it is going to have, I'm not going to use that one, I'm going to use my set value as a starting point. So smoothing one is going to be an interesting one. Now the smoothing one, I'm going to say that this can never be applied per biome for now. So if this is being run where that is not equal to null, in this case I am actually going to return, but I will log an error. Not supported as a per biome modifier. Is not. And let's output the biome that this is obviously attached to, just so we can easily find it. So this is not going to do any biome checking. So we've already got a strength, but with smoothing, we can pick the size of area we smooth over. So what we have is our smoothing kernel size. Smoothing kernel size. So this is how many samples around us we bring in. So I'm going to initially say 5. So what we actually need to do is we need to do this in 2 passes. Because firstly we need to generate our smoothed values and then we apply them. So I actually need to have here a new height map. This is going to be smoothed heights. And that is a new float by map resolution. And I also need to know how many samples I'm grabbing in a particular location. Actually, no, I'll know how many samples. So firstly, what I'm doing is populating this. So I need to, in this, height sum is 0, because what I'm doing is I'm averaging. That's exactly what I'm doing by smoothing these values. So num values. So then I need to loop over that smoothing kernel size. So for int y delta starts at negative smoothing kernel size. Y delta needs to go up to and including the positive value of that. So that's our y delta. And then we have a similar thing with x to gather the values. So this will be my x delta. X delta and x delta. Excellent. So we've got that. So sum the neighboring values. So in this case, I can work out my working x, sorry, working y is going to be y plus y delta, because I need to check working y is less than 0 or working y is greater than map resolution. We skip because it's out of bounds. Then I need to do the same here in x. So my working x is 0 is x plus x delta. If that is out of range, then I also skip Otherwise, I can then add in my height sum. So otherwise, height sum, add in my height map, working X, working Y. The reason we have this second copy is because otherwise we'd be influencing our smoothing as we're doing it. So when we calculate the smoothing for one location, that would then impact the smoothing for another and another, and we don't want to do that. We just want to be doing the smoothing, calculate the smooth values, then we apply them. It also lets us control how strongly it smooths as well. We can apply an intensity change there. So we add in our num values. We then store smooth heights, xy, is equal to height sum divided by num values. So we store the smoothed height, store the smoothed, aka average height, then we can apply it. Now, we don't need to use height map scale because we haven't actually had to convert to meters or from meters. We're just able to work with our 0 to 1 values. So we can then say that that's going to be equal to, we lerp between our existing value and our smooth value. That's all we need to do the smoothing. And I can set that up then as a post modifier, which we'll be able to see on the data. So post-processing, so put in the smoothing, and I'm going to actually remove just the pure random one. So smoothing, I'm going to leave it at 5. And let's see what it looks like if we smooth across that. It's going to run. And so 5 does a lot of smoothing. But that terrain also looks pretty damn cool, I'm going to say. That's a fairly nice looking terrain, but we can see what happens as we change that smoothing value. So if I change the smoothing kernel to be more like 3, so a much narrower range, then it's preserving more of the sharp edges. I can also, with that, I could say, no, let's go back up to 5, but let's only apply it at 50% strength. So we've got two different ways we can control this, both the range that we're smoothing over and the strength. So you can see 50% strength, we still get these really hard edges. So with that, we probably don't want to have it be that hard an edge. We could try, okay, well, what if we increase the range? Now that will run slower. Smoothing modifier is going to be very slow because it's doing multiple passes over the data. And we can still, with that strength, still get those sharp edges. So I would generally keep the smoothing applying at full strength, so we're using the smooth values, but we keep it as a more restrained sort of kernel size. 4 to 5 I find is usually pretty good because that keeps these big features that we have from the terrains, but it then makes it still be a little bit of more traversable. We smooth out those sharp transitions between areas. And I could add back in the tiniest amount of random just to influence some of these areas where it's a little bit too uniform. So a little bit of random there is just going to slightly distort those values a little bit. So we can see we've got a little bit, and it's, if I switch to shaded wireframe, it's a little bit easier to see. So we've got a little bit of bumpiness there from that random, but otherwise we've got a fairly easy to traverse terrain. That's one that we would easily be able to sort of move across. It will vary slightly each time we do generate because obviously random, it's starting at different values each time. So just to recap what bits we've done. So what we did was we started having our biome map. We switched that to be a specific low resolution so that we could generate it really rapidly and then upscale it. Upscaling it, though, means we need to deal with the fact that we can't just interpolate between the two biomes necessarily. So we had to do a bilinear filtering where what we were doing was we were snapping to the closest candidate biome. So that was an important thing, that we were snapping to the closest candidate biome with that. And then that gave us a high resolution one. Then we were needing to modify the terrain, which we wanted to set up where we could have some initial height changes. We wanted to also have stuff that was per biome and then have some post-processing. So we went this approach of having prefabs to hold that data so that we can stack the individual components and have the order of those components matter for actually creating the terrain. We set up a bunch of different modifiers for doing things like setting values, for offsetting, adding in random, adding in noise, doing some various smoothing, and we were applying that. And we made it so that our modifiers were actually tied to which biome. So they wouldn't run if it was for a biome that they didn't actually own, so that we could get that variation. So we haven't looked at texturing yet. Texturing is going to build on top of what we've done with this, because the texturing follows a very similar process. We will have modifiers for painting those textures on the terrain. We'll be able to use, again, a similar process for applying spawning of objects. So the spawning of things can actually be done using a similar modifier-based approach as well. So if you're wanting to look at extensions that you could do to this, though, that interpolation, that scaling up of the maps, was actually one of the big ones, where what you could be doing is you could make it that a location can have multiple biomes there, but has different strengths. Because we already have, all of these modifiers have a concept of strength. So that would actually be a process where you could have multiple biomes in the one location, and it applies each sort of modifier with a different strength based upon that particular biome. That would be a set of extensions that you could do there. Now, the next time we take a look at this, what we're going to be doing is we're going to be adding in textures, and we're going to be spawning objects to finally sort of wrap up the generation of our world here. But that will be all for this one. Thanks, folks. That is all for this video. If you're looking for the project, you'll be able to find it up on GitHub, and I've put a link to that in the description below. If you've got any feedback, any questions, please chuck in a comment. And if you're looking to find ways to support the channel, chucking in a like or subscribing to the channel is always a big help. If you're looking to go further than that, then I do have a Patreon set up, and any support there is super appreciated. And there's a bunch of different things that you'll get as part of being a patron there. And the big thing is, it's going to help me make more cool things like this, which is going to help more people like yourself to be making more games, which is awesome. And that is all for now. Thank you.